Hello, Math 1 students. This is Mr. Liao, and this is section 10.4, Proofs with Perpendicular Lines. The goals for section 10.4, we're mainly going to do the first goal, which is to find the distance from a point to a line. That's the overarching goal. The others, we're going to skip the constructions this year because of the lack of class time. We'll do a proof, and we'll do some word problems. You'll do one on the homework, basically looking at how you measure the shortest distance from a point to a line. So this lesson is all about finding a distance from a point to a line. And that distance is the length of the perpendicular segment from the point to the line. So notice here's point A and there's line K. So the distance from a point to a line is the perpendicular segment. That represents the shortest distance from the point to the line. So here is point A there. To find the distance from point A to line K is going to be line segment AB. Notice that that's the shortest distance from the point to the line. If you go that, or that, or that, none of those orange segments are as short of a distance as it is from A to K. So if you're saying trying to reach a river and line K is like a river, you're going to basically go from point A to B. That's the shortest distance to get from that point to the line, and that represents the perpendicular distance. So look for that right angle mark. Example 1A, find the distance from point A to line BD. So you've got three choices here for the line. That's the distance from A to BD. You want to pick the segment from point A, which is at -3, 3, to line BD. So you have between AB, AC, and AD. You want to pick the segment that's perpendicular. So which segment is that? That's clearly segment AC. Notice that AC, that segment intersects line BD at a right angle. So now to find that distance, you need to use the distance formula, which is basically constructing a right triangle and using the Pythagorean theorem or using the formula, which you'll see on the next slide. So to find the distance from A, which is at -3, 3, to C, which is at 1, 1, you're going to need the distance formula. So if you want to use the distance formula, you can, but I'm going to construct a right triangle here using points A and C. So notice, if you're going to draw a right triangle, the height of that triangle is 4, and the width of that triangle is also 4. So the length of AC is going to be the square root of 4 squared plus 4 squared. If you want to use the distance formula, you can see that it's -3 minus 1, the difference in the x-coordinates, squared, plus the difference in the y-coordinate squared, 3 minus -1, which is basically the square root of 4 squared plus 4 squared. That's the square root of 32. Take the square root of that on your calculator and round it to your nearest tenth, and it's 5.7 units. So that is the distance from point A to point C, which represents the distance from point A to line BD, the perpendicular segment from point A to line BD, which is AC. Example 1B, I would like you to consider trying this on your own before I give you the answer on the slide. If you just want to listen, that's fine too. Find the distance from point E to line FH. Again, you have three choices. You have EF, EG, and EH. Which segment should you use? Well, you're going to use segment EG. Notice again, that's the segment that's perpendicular from point E to line FH. So now we're going to use the distance formula again from point E, which is at -4, -3, to point G, which is at 1, 2. So again, if you construct a right triangle, you see that the width of the triangle is 5, the height of the triangle is 5. So if you were to use the distance formula, taking the difference in the x-coordinates, 1 minus -4 squared, and the difference in the y-coordinates, which is 2 minus -3 squared, you get the same thing as if you were doing the Pythagorean theorem. So EG is the square root of 5 squared plus 5 squared. Those are the lengths of the two legs. Add that up, you get the square root of 50. Take the square root of 50, round it to the nearest tenth, and you see that distance is about 7.1 units. So that's how to find the distance from a point to a line. You can look for that perpendicular segment. Next, we have a couple theorems. First, we have the linear pair perpendicular theorem. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So what you're given is that angle 1 is congruent to angle 2. If those angles form a linear pair and they're congruent, they each have to be 90 degrees. Since those angles are each 90 degrees, then line G has to be perpendicular to line H because these have to be right angles. Now we have the perpendicular transversal theorem. In a plane, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. So here you're given lines H and K are parallel. Then you are told a line J is perpendicular to line H. You can see the right angle symbol. If that's true, then line J has to be perpendicular to line K. So if you were to draw a right angle box there, that's what it's saying. Now if you think about why, you know that this is a right angle. So if that's a right angle, then since H and K are parallel, this also has to be a right angle here because those two angles are corresponding angles. And if the lines are parallel, then those corresponding angles have to be congruent. So if they're congruent, then it means lines J and K also have to be perpendicular because that angle also has to be a right angle. So that's the perpendicular transversal theorem. If basically you have parallel lines and the transversal intersects one of those lines and it's perpendicular, it's got to be perpendicular to the other line, which means the lines are perpendicular. Finally, we have the lines perpendicular to transversal theorem, and this one's a little tricky to apply. You'll see on the homework. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So here you see M is perpendicular to P, and N is perpendicular to P. If that's the case, lines M and N have to be parallel. And this is basically the offshoot of the corresponding angles converse, where here you have corresponding angles that are congruent. In this case, they're both right angles. Therefore, M and N have to be parallel lines. So we're going to do a quick proof of the perpendicular transversal theorem, which was the second one we went over. So you're given lines H and K are parallel, and you're also told J is perpendicular to H. You can see the right angle symbol that's marked. Angle 2 is a right angle. Now we are to prove that lines J and K are perpendicular. So we're basically going to do what I just kind of went over orally, and you can see how it looks on a proof. So statement 1 are the givens. H is parallel to K, and J is perpendicular to H. That is a given reason. Statement 2, the measure of angle 2 is 90 degrees. And this is because of the definition of perpendicular lines. So perpendicular lines form right angles. Right angles measure 90 degrees. And you're told J is perpendicular to H, so angle 2 has got to be 90 degrees. Statement 3, angles 2 and 6 are congruent, and that is because they are corresponding angles. The corresponding angles theorem says that if two lines are parallel and they are intersected by a transversal, in this case, H and K are parallel, J is the transversal, then corresponding angles have to be congruent. That's angles 2 and 6. Statement 4, the measure of angle 2 is equal to the measure of angle 6. That's the definition of congruent angles. The definition of congruent angles says if two angles are congruent, like it says in statement 3, then their measures have to be equal, which is why M2 is equal to M6. Statement 5, M6 is equal to 90 degrees. And this is the transitive property of equality. If you take statements 2 and 4, you see that measure of angle 2 is 90, measure of angle 2 is equal to measure of angle 6. Therefore, since measure of angle 2 is equal to both of those two angles, those two angles have to be equal to each other. So M6 equals 90 degrees. Finally, J is perpendicular to K, and the reason is the definition of perpendicular lines. So the same reason in statement 2, we went from M2 equals 90 from J perpendicular H. Definition of perpendicular lines say that perpendicular lines form right angles. The definition of perpendicular lines also says that if there's a right angle formed, then the two lines forming that angle have to be congruent. So take a look at homework 10.4 from the Big Ideas website. Again, log into bigideas.com. Use your log on with Clever and log on to Clever using your MUSD account.